Good afternoon, everyone. After lunch, of course. Thank you for introducing me, and also thank you, Academy, for inviting me for this talk. Uh, we have heard so much about technology since morning. Let's talk about us today. It's about the civilization, it's about the people, it's about how we evolved and why we disappeared. So this talk is a work of several years with my PhD students and also several collaborators. We would like to examine whether or not uh, a large river, the so-called Saraswati, was actually responsible for the demise of the famous Harappan or Indus civilization. And I hope I'll be able to convince you, end of the day, that it was not. That's very contrary to the belief we have had so far, but we have a huge data set collected over the period of last 10 years or so, and I am quite confident of this opinion. So we all know about the Harappan civilization. We also know about how the other civilizations developed in contemporaneous with the Harappans. We have a reasonably good idea of how the civilization expanded, matured, early, mature, and late civilizations, and so on. We have a reasonably good time scale, time constraint in terms of the evolution of the civilization based on a very sound and a very solid archaeological record. Now, this information was a little bit complex, became a little bit complex when becomes a little bit complex because we called this civilization, or we call all civilization basically, as a river-based civilization, riverine civilization. And when we look at the modern landscape of the northwest India, and particularly where most of the civilization sites are located, there are no large rivers today, right? You have Sutlej Valley here, and then you have Yamuna Valley here, and this entire region between the Sutlej and the Jamna, where most of the Harappan sites are located, I'll show you a map in a minute, there are no large rivers today, right? So therefore, when you see, we will of course talk about all of these windows which I have shown here. So when you look at the distribution of the Harappan civilization site, particularly the mature sites, which is 4.6 thousand years to 3.9 kilo years, which are highly concentrated in that region where no present-day system actually, goes through. This is actually an interflow region between the large Sutlej Valley and the Yamuna Valley, the modern Yamuna Valley. The obvious question arises: why are these numerous settlements scattered around these lines, around these areas? And that led, and of course the hypothesis and the thinking started to grow when we discovered this very famous paleo channel, which is the so-called Saraswati River, which is flowing through that same region, which is presently the desert, and presently there are no modern drainage systems here. This was discovered because we had access to some really good thermal infrared images. You don't see them in the normal satellite images anyway. So then the hypothesis started to grow that yes, there is a river culture hypothesis, and the debate started. And the hypothesis was immediately made that most of these urban settlements, because they are clustered around the paleo channels, and they must have been related to rivers. And the so-called mythical Saraswati River, which has been referred in the Vedic text, that was linked to that, and that it was suggested that the civilization disappeared because the river disappeared. So very obvious and a very logical conclusion to do. There's nothing wrong about that. But the problem with this hypothesis was that, first, that yes, we discovered the paleo channel, very broad thermal or infrared image and all of that, but we had no information about the subsurface existence of that paleo channel, how big the channel was, how thick the deposits were, absolutely no information on that. We had no information about when and how the river disappeared, no timing constant, although there was very strong timing constraints on the archaeological data set, but no information about the migration or the disappearance of the river. And of course, no information on the causal factors of such large-scale shifting or disappearance of the river as well. The consequence of tectonics, climate, nothing was known until about a decade ago. But we kept on arguing about the river culture hypothesis, etc., which has been true in many other parts of the world as well. So we started this work about a decade ago. We used multiple tools, resistivity surveys. So our job was first to detect the subsurface continuity of the paleochannel. Our job was to detect or map the channel in the subsurface. Our job was to date how old these channels are and how and when they were deactivated. And we use, of course, multiple techniques of resistivity, drilling, coring, OSL technology, and then, of course, and also, of course, to find out where these sediments came from to form these large sand bodies. So this is the processed, image. When you see these paleochannels, these are some very important archaeological sites which are located very close to this river, very large urban settlements like Kalibangan, Rakhigarhi, and Banavali, and all of that. And then you can also see a slight trace of a paleochannel here, which connects to the modern day Sutlej. Okay? So all of this was, this also was a very specially processed image because you don't see anything on the modern day image today because all of these are very highly agricultural areas. So you don't see any trace of these channels today on the modern satellite images. So we had to process these images a little bit. And then, of course, you have the modern Jamuna somewhere here. So this is how we went about. To answer the first question, we ran a series of transects for the resistivity survey. It's a very blunt technique. It doesn't give you a lot of information, but it has the power to distinguish the sand and mud, and of course the hard rock very nicely. So we could very nicely map that, yes, there is a subsurface extension of these channels, and these channels are about 20 to 30 meters deep. Where deep, 20 to 30 meters deep, as inferred from the thickness of these sand bodies. So we ran transects here, we ran transects here. So that transect, this transect, corresponds to this, and you can see again almost 20 to 25 meters thick channel bodies. And here again, you see the thick sand bodies up here. So we actually, what idea was, of course, we also had several other transects which I am not showing, but we could very easily establish that yes, there is a very nice subsurface extension of these channels. So therefore, and these thick bodies of sand cannot be deposited by a small, by the way, along this channel, what we run today is a small seasonal Ghaggar river, which actually originates somewhere here and then drains for like 15 days a year, for example. So obviously, it's sitting in the same old valley, but this kind of a river is not capable of, of generating such large 25 to 30 meters thick deposits. So therefore, the first answer was done that yes, there is a large, large river, signature for large river which exists along these, inferred paleochannels. Then we went about drilling several holes. We drilled about more than 11 holes, 11 holes here, and then also some other holes in the Jamuna Valley later on. And we were trying to map the characteristics of these sand bodies. We also tried to date the individual sand bodies in terms of the OSL dates. We also tried to do the compositional analysis. We also did the provenance analysis. So there's a series of analysis which actually went on these cores. These were one of the first cores, first detailed cores which we obtained from this kind of a region. Then what we got was very startling. This is a transect, somewhere here, very close to a place called Kalibangan. And what we saw was a very nice amalgamated multi-storied sand bodies which were basically lying on a base of what we called as what are the Aeolian sands. All of these were sand, but these were very distinct. The Aeolian sands are very distinct, as most of the sedimentologists would know. So they were fluvial sands, multiple stories of sand, which basically indicates that there were multiple channel activities which were recorded in this entire transect, and you can see the dates were also done. So there are shifting of the channel belt from here to here, here to here, and so on. What you should also mark that there is a very nice demarcation of where these sand bodies are ending. The arrows are marking there, and note the dates are ranging from about 25,000 years to something like 23 and 13,000 years and so on. These are the markers which basically tell you when this large river activity ended. And please remember the dates, 25 to 12, 13,000 years back. And then there are two sets of deposits. We can easily see there is a older deposit and there is a younger deposit here as well, and so on. Now, what this tells us that any large activity of a river ended, around 12,000 years or so, or close to that, basically. Of course, there were minor sand bodies, which you can see here, and also in other locations, which continued up to about 8,000 years or so 7 to 8,000 years, which means that there was no activity of any major river, after about 12, 10, 8,000 years or so, okay? Then of course we had another transit somewhere here, along the Satluj, the paleo channel of the Satluj. We got similar information from there as well. We again had the last fluvial activity reported at about 10, 11, and 8,000 years as well, which means that again, in the entire region of the Paleo-Satluj Valley or Paleo-Ghaggar Valley, whatever you want to call that, the large river activity ended by about 8,000 years. The Harappan civilization continued up to about 4,000 years, okay, which means there is a gap of at least 3 to 4,000 years between the demise of a large river and the demise of the civilization. Therefore, they cannot be contemporaneous. There is no way they can be contemporaneous. That's one. Then, so that's what I just said. Then we also looked at what were the reasons for their disappearance. We looked at detailed depositional history, and we could relate to several depositional events in a time scale of something like 80 to 90,000 years until about 4,000 years, and we recorded several activities of fluvial accretional activities, and which were strongly linked to the climate change which happened over the time period, over this kind of time period. So that was one. After that, we again had another problem to solve, and that was the Jamuna lake. How much was the contribution the Jamuna was made? Because again, the hypothesis has been that this branch of the Satluj and this branch of the Jamuna, they both actually made this so-called large Saraswati river, which was supposed to be at least 4 times larger than the modern day Ganga system, for example. So therefore, this connection was also equally important to examine as to what was the role this was playing. So we actually had a very similar strategy. We again did a very detailed transects of the resistivity surveys. The paleo channels were existing, but their subsurface existence was not known, and we could establish again that there were 15 to 20 meters thick sand bodies which are located, at several points. And there are many paleo channels, around there. So we took up a transect here. All these black lines which you see are actually paleo channel traces which people had been mapping before. And along each one of them, we could discover that there are paleo channel thick sand bodies which are located there. And then these are the cores which we obtained. We analyzed them for centimeter by centimeter, looked at detailed ecology, species, and interpreted them in terms of stratigraphic development and all of that. And then we again had the dating of the cores done. We generated almost 45 OSL dates, and we could discover that again, this part of the valley, the Jamuna Valley, also went through very similar stages of aggradation, but at different times. There were 4 different phases which we discovered. The only other interesting point which we discovered that this valley was abandoned almost 18,000 years ago, much before the Satluj was abandoned, and therefore this also may not have contributed significantly or at all, in fact, to the demise of the Harappan civilization again. And then if you start looking at how this whole drainage systems actually developed, this is the model which we developed. And so there was basically 2 series of avulsions. One was one along that, and then which happened around 18,000 years ago, and then this happened around 8,000 years ago. And this is the reconstruction which we did for the last 80, 90,000 years, and different phases. So it all happened. This all was reconstructed through the sedimentary record which we had, the dating data we had, and so on. So what is very well established now that the Jamuna migrated 18,000 years ago, the Satluj migrated 8,000 years ago, and the Harappan civilization continued until 3.9 or about 4,000 years ago. And therefore, they were certainly not, the demise of the civilization was certainly not contemporaneous to the large rivers. And of course, the modern day landscape which you see today has always been reworked by the smaller rivers, etc., and so on. Now we had one more problem to solve, that, okay, we have large sand bodies sitting there. There is a subsurface existence of that, but where did the sediments come from? Are they actually coming from the foothills, or are they coming from the large, catchments of the Himalaya? Any large river which was draining in that region must be originating in the large part of the Himalaya. And we have a wonderful technique, in geology, to sort of a fingerprint the sediments. We use what we call the uranium lead dating of the zircons, which we extract from the sediments. And interestingly, each part of the Himalaya is actually known by a very well-established range of the UPV dates, for example. So the high Himalaya, for example, are 500 to 1,000 million years. These are Trans-Himalayan and Karakoram, 50 million years, and 1800 million years, and so on. So this has been established by several workers, and of course the idea of this work was very different. They wanted to understand the exhumation history of the Himalaya, etc., and so on. But we used that for testing the provenance, and then we analyzed several samples from our cores, all the cores which we had, some samples from all the cores, and what we found very interestingly that almost all the cores are centered around 500 million years, which is actually very similar to what the Satluj actually shows. Okay, very, very close to the Satluj, which means that most of the sediment were derived from a Paleo-Satluj river, which was draining a large part of the Himalaya, was draining in a different direction at that time, and then it was obviously avulsed. Then we also use another technique which is called argon-argon edges, which is basically the pooling edges of the mica. Again, let's not get into the details of that. But again, this is also used as a source, and again, it suggested that almost all the core sediments have an age which is very similar to the modern day Jamuna. Okay, so therefore modern day Jamuna and Satluj as well. So there are overlaps of Satluj and Jamuna dates here, and these are the two large rivers which might have contributed to that. This is basically what I just showed you from a geomorphic reconstruction using sediment cores. So the sedimentological data, the geochronological data, and this compositional data, they all support this kind of a hypothesis here. And then there is a modern analog for that. If all of you remember the 18th August event of Kosi, where one river shifted by more than 100 kilometers in just one shot. So such events, such mega migration of rivers are known, even today they are happening. Of course, the reasons may be different. There are anthropogenic factors also coming into picture, but such large scale events have happened, in the history as well, historical scale as well as in the geological time scale. So what we therefore believe that the settlements around the Indus or the Ghaggar and Satluj and the Jamuna rivers, they actually developed when these valleys were abandoned and the floodplains were stabilized, and then people started to settle in there rather than staying in a river which is 4 times bigger than the Ganga flooding every time, and so on and so forth, right? So therefore, when these rivers reduced their mobility, they got confined in the incised valleys, then was the time for the civilization to actually mature, for example, in that region. So therefore, our conclusions are that yes, there is a subsurface extension of these pilot channels which we see on the satellite images, but then the timing of these rivers, for which they flowed in that region is much earlier than the demise of the civilization, and therefore it is highly, highly improbable that the Indus settlements actually flourish because of the perennial source of the rivers and so on. What we believe that the confinement of these rivers and the stabilization of the floodplains, plus the development of agriculture, water resource, the storage structures, all of that actually played a very important role, to stabilize these settlements. So what we believe that it is actually the departure of the rivers rather than the arrival which triggered the growth of the urbanism and not the other way around. And I would like to sincerely acknowledge the help of all of these people. This entire work, is actually an outcome of 2 PhD students, Rajiv Sinha and Imran Khan, and then of course several collaborators across the world, and funding from many sources, including Ministry of Earth Sciences, SCRB, and also Royal Society and UKD. Thank you so much for your attention. I'll be more than happy to take a few questions.
Question: if the rivers receded or died 8,000 years ago, and the Harappan civilization lived from between, let's say, 6,000 to 4,000 years, where did they get their water from?
Well, see, what I'm trying to argue is that there were no large rivers, but I'm not saying that there were no rivers at all. There were small rivers there, and the population was not really large at that time, so that was enough to sustain them. That's number one. Second, remember that by that time, the agriculture was very well developed. The Kalimantan has the oldest agricultural sites in the whole world, where we discovered agricultural signatures about 9 to 10,000 years ago, for example. And then, if you also look at the archaeological sites, they had very nice water storage structures. So they knew how to store and water as well there. So I think there was enough water around to sustain such kind of a small population civilization, by the way. Then, after 3.5, 4,000 years ago, there are other hypotheses which are mostly true, that there were climatic transitions happened and all of that. So that, most of us know that.
I have another uninformed question.
Yes, please.
I have come across a suggestion put forward not by earth scientists but by some archaeologists, and I can't testify for their authenticity, that actually there was up the stream of the Saraswati at some point in the past, some very strong earthquake, as a result of which what is called river piracy took place, and the water of Saraswati was largely diverted to some eastward flowing stream, and there has been attempt to relate this to the fact that the Yamuna, which meets the Ganga at Allahabad, Sangam, is also kind of mythically called as containing the river Saraswati as a result of this river piracy.
Okay.
Do you have any comment on that?
I've got your question. See, I have not commented at all on how and why these rivers arose. Okay, that's a very separate question to answer. There are strong models which are not very authentic as of now, but there are many possibilities: earthquakes, tectonic events, large floods, and all of that. So they are very separate questions. I think that the fundamental point I'm trying to answer here is that there was no river when the civilization was exists. That's number one. So, but then the shifting of the rivers could have happened by multiple factors, and we are yet to understand that. That needs a very separate set of investigations to do that. Earthquake is just one possibility. But then there are no documented records of that. These are again speculations, by different people. But there are possibilities. So that's a very separate question.
Is there any geographical data which can reveal whether such an earthquake ever?
No, there are people who work on what is called as a paleo-earthquake analysis, but as of now, we have no data to suggest that there was an earthquake at that time which might have triggered. That's one. The second point I wanted to raise here that is again a misnomer that the civilization disappeared or died. Actually, it did not happen. The civilization do not die. In particular, this civilization did not die. They only migrated. So what happens is that they migrated to the north, towards the Satluj exit and all of that, and they also migrated to the east, to the Ganga Valley, for example. So the civilization did not actually die. It was just because the resources became limited, the monsoon, declined, the precipitation became lower, the resources became scarce, and they migrated to the east, for example. So these are all sorts of misnomers which are there. So they migrated to the Ganga Valley and then they survived there. Okay.
As far down as up to places like Bihar, doesn't it?
Yeah. So this is a point. What we are today is just a continuation of the same civilization in a different way.
There are archaeological evidence.
Yeah.
There's a question.
Yeah, please.
Yeah, I'm just wondering, the entire very interesting scenario of meandering of the rivers, how does this collaborate with the marine records? Because we have some, similar evidence coming from the strengthening of the rainfall and strengthening of the monsoon.
Actually, I showed you this data.
Yeah. So how we can try to collaborate this evidence from the marine data?
Yes, it's a good question. See, what I showed you here was, this correlation with the summer monsoon factor. And as I mentioned in both the reports, from the Ganga as well as the Jamna, we have very strong climatic, correlation between the major phases of aggregation and the climate events. And most of this data is coming from ocean records, by the way. So the compilation of the climate records has come from the ocean. There may be minor lags, which are part of the system, but broadly, we do recognize that most of these climate factors are correlated with the events.
So because there is a clear understanding that the weakening of the,
Yes.
the southwest monsoon and the weakening of the northeast monsoon
Yes.
during that time period. So that must be reflected.
Yeah, that report is here only. This is literally the marine report. Actually.
Good. That's very interesting.
If there are
A role played by the tectonic thrust towards the northeast.
Yeah, I was trying to answer that same thing here. That I mean, see, you to move a river like Satluj or even Jamuna, you need some external forcing to happen, right? It could have happened through tectonics, but it is not essential, and that is the reason why I give you the example of the Kosi River. The Kosi River migrated by 100 kilometers in one shot like that. And there was a different reason, there was a sedentological variation, the river bed was so high that it just could not be contained within the river, within the channel, and it was. So there are alternative hypotheses available. It is not necessary that tectonics would have played a role only. There are other reasons as well. But I think we are yet to discover that. We have no documentation on that.
It's from the Himalayas.
Yeah.
Himalayas also do contain marine sediments.
So they will be reworked, and the fossils are very unlikely to survive. So yes, the sediments are coming from the Himalaya only, but these are all reworked sediments, right? They have undergone several cycles of deposition, so it's very unlikely that these tiny forms will actually survive. We haven't discovered anything. In fact, the best sediments, that type of sediment where these are preserved are muddy sediments. We are looking at sand material, which is very hard to